Okay, so the next test here, class 9 maths. Okay, the test 13.3a. This will include the introduction. Then, okay, let's just do like this. This will include the under exercise 13.3. This will include the introduction, the formulas and all. And then question B1, 2, 3, 4. This we'll find on textbook pages. Okay, pages 233 to 237. 237. Let's start with the introduction. So in this chapter we have started with the solids, cuboid, then cube. Then the next was, I think, yes, before the cone we did the cylinder. Yes, cuboid, cube, cylinder, and now we're coming to a figure called cone. Okay, so let us just start with the question. What is a right circular cone or simply a cone? So this one, it is okay, a cone. A cone is a solid formed by rotation of a right triangle about one of its perpendicular sides. Okay, one of its perpendicular sides. So let us say this is your right triangle, and draw it along with me. Now A, B, C. We know that right triangle means out of the three angles in any triangle, if one angle is 90 degrees like this, that's a right triangle. So the two perpendicular sides of this right triangle are BA and BC. So keep any of that two perpendicular sides, either AB or BC, fixed, not moving. That means let's say AB fixed. Then you rotate the remaining triangle, then you will get like this or not. Structure solid. So if you rotate like that, right triangle, flat right triangle, 190 degree side, fix and rotate this portion here like this, one rotation, then you will get a figure like that I've drawn just now, like this cone. So this figure is having circular bottom or base. This figure is called a cone, solid. So here the radius of this circular base, the radius of this circle here, means from here to here, is called the radius of the cone. Then if we join here, this one here, the fixed point, or rather the sharp point in this solid figure cone, the sharp point here, the sharp point here, this sharp point is called vertex of the cone. This point here, this is called the vertex of the cone. So from the vertex you join it to the center of the circular base. This is the center. That distance or line is called height, or it is also called vertical height. Okay, then so this is the radius, this is the height, and this portion here, from here to here, measurement from here to here, which is slanting, is called the slant height L. Slant height is the distance from here to here to this slanting. Height is the distance from the sharp point to the line joining the sharp point vertex to the center of the circular base, this vertical height or height. So this is height, or we can also call it as vertical height, and this is of course the radius. Okay, so these are the 3 dimensions of a cone. Okay, now let us derive the formulas of a cone. Let's start with the next one. First formula, let us say formulae of cones. So the first one, let us determine the curved surface area. Let's say CSA. So for that, let us take a cone. So this is the cone, let us say. One I have in my hand. This is a cone right here. This is a cone. This is a cone. So this we're going to draw here. So this is the representative cone. Draw it a little bit smaller if you want. So this is this cone. Let us say this is the figure 1. Figure 1. So the distance from here to here, this one is the radius. Just now we did that. The line joining the sharp point to the circular center is the height. And then this from here to here is the slant height, L. Vertical height or height, and radius. This is the cone figure 1. So we have to find the curved surface area. Means right here this is a real cone. This portion is the curved surface area. This portion is flat, circular flat, so that's not curved surface. So curved surface means this one we have to find out. I'm going to derive the formula. So let us cut it open. So here, see, step 1, cut open the cone, that is figure 1, into figure 2. Then we can write, okay, then we get a sector. You get a sector. I'm going to explain this. So this is the cone. So you cut it open now with a scissor, and you'll get shape like this shape. So let's draw that figure 2. So step 2. So we're going to get here figure 2, that is like this. You're going to get, as you cut open this cone, you're going to get a shape like this. So this is called sector. Sector means, let me explain it. You do not draw. Circle is their center. Draw one radius, then another radius, then the region surrounded by these 2 radii, and this arc here is called minor sector, and the region surrounded by the 2 radii, and the big arc here is called the major. Let's take the minor sector. Then sector means region surrounded by 2 radii. So this is the radii. This is the radii of the sector. So this is figure 2, representing the curved surface area. So once you cut it open, the curved surface area has become a sector. Curved surface like this, you see. Whole thing I've shown. Cut it open and it is now flat sector. Right, so this is sector. Now, before you cut open, this portion was L. As you can see here, L. So this line L, this line also L. And before you cut open, this was a circle. This portion was forming the, this portion was here, was forming the circle. And we know that the distance covered in going one time around this circle is called circumference. So we go to say here, therefore, that is curved surface area of okay, let's go a little bit down. Figure 2. Okay, curved surface area of cone, that is in figure 1. This curved surface area, this here, has become a sector, has become equal to area of sector shown in figure 2. Area of the sector shown in figure 2 is exactly the curved surface area before cutting open, right? So this is what we're going to get. Now, before we cut open, this portion here, before we cut open, was forming a circle. Distance from here to here, one round distance circle, is called circumference. So this distance from here to here is circumference of a circle formula 2 pi r. Right, this is because radius of this circle is r. So that 2 pi r is now length of arc, right? So here, the length of arc from here to here. So we can write here, area of sector formula is half into, there is one formula for area of sector, you just memorize it, know it, half into length of the arc. Okay, length of the arc means from here to here, multiplied to radius of the sector. Okay, so now that will give you here equal to half into the length of the arc, means arc of the sector. This one from here to here is called length of arc. This distance from here to here is 2 pi r, so we put here 2 pi r into radius of the sector is distance from here to here is called radius of the sector, radius of the circle, L. L is the slant height of the cone, but when you cut it open, L has become the radius of the sector. So radius of the sector is L. So if we cancel this 2 and 2, we're going to get equal to pi RL. So formula for curved surface area of any cone is pi RL. Just these 3 steps are to make us understand how the formula is coming about, and the last is what we have to only memorize, is the last step, curved surface area of a cone, pi RL. So this one, number 1. Then next formula, let us go to second formula, total surface area, or we also call it a surface area of a cone. Write it down. Will be equal to, look at this figure, we're going to use the same figure. Total surface area will be this curved surface area, of course, plus normal cone. This is closed, okay, this is closed circle, so this is also area of the circular base. So we write here area of the circular base, means lower portion of the cone, this one. So this area of circle plus the curved surface is total, right? So we write here that will be equal to curved surface area we got just now, formula 1 pi RL, plus area of any circular base or any circle is pi r square. So we write there pi r square. Then see here pi r common, so let us take out pi r common outside. Then inside will be L plus here r gone out, so pi r gone out, r into r square, pi r into r square. So pi r into L plus r is the formula for total surface area, second formula. Then the third formula, that's called subheadings. Let's just write here the third one. For this, let us write here, draw the cone once more. Draw a cone, and then let us derive this from the third formula. Sub-formulas. We know the distance from here to here is called the radius of the cone, this one, and the distance joining vertex to center of the circle is height, and this is slant height. So there are formulas that we're going to need. A, to find L, when H and R are given in the question, we'll use root over H squared plus R squared. L equal to root over H squared plus R squared. Memorize that. B, H, if you want to find when L and R values are given, will be root over always L squared minus R squared, not R squared minus L squared. Memorize it properly, okay? C is R will be root over when L and H are given. When you find R, then root over L squared minus H squared. These are the formulas. So there are 5 formulas we're going to need in this exercise. They are total curved surface area of cone, pi RL, total surface area of cone, pi R into L plus R. And these 3 formulas, L equal to root over H squared plus R squared, H equal to root over L squared minus R squared, R equal to root over L squared minus H squared. These are the formulas. Now once we're done with that, let us start the exercise. I think we can do that in the next class. I think we can do one sum, yes. So let's continue. So these are the formulas we're going to have to need to keep in our mind. First one is curve surface area of cone. First formula, pi RL. Second formula, total surface area or surface area of cone. We need to clearly memorize this, pi R into L plus R. The third formula, A, first one, find L, root over H squared plus R squared. To find H, root over L squared minus R squared. To find R, root over L squared minus H squared. These are the formulas that we need to remember clearly. So this, let's keep it like that. Let's start with now B1. So let's start. B1 is the question, diameter of the base of a cone is 10.5 centimeter and slant height is 10 centimeter. So let us draw this cone. There is a cone. Clearly, question is saying diameter of the base. Diameter means from here to here. From here to here is radius, 10.5 centimeter. Slant height means from here to here is 10 centimeter. These two are given. We have to find curved surface area. Here in question B1, for the given cone, here R representing radius, so this diameter 10.5 divided by 2, because radius is diameter divided by 2. So if we divide this, 2 5s are 10. Now in hand point, so 2s are 4. 5 is there, means 1 remainder, so 0 can go at the back of that, on the right side of that 1 remainder, then 10, 2 5s are 10. So radius can be 5.25 centimeter. The slant height L, so this is the radius of the cone, 10 centimeter. So it's slant height, as clearly given in the question. Find the curved surface. So curved surface pi RL, R is there, L is there, so we can easily find out. So therefore its curved surface area will be equal to pi RL. So it will be, pi is not given, means 22 by 7 into R here, 5.25 into L here is 10. So let's do that. And area means 2-dimensional, so centimeter square. You can write it once like that. 7 ones are 7 here. So 5 is less than 7 means you can put 0 first point. Then 5 will go to the left of 2 on the right of point, so 52. 7 sevens are 49. So remainder will be 49, 50, 51, 52. So 3 remainder. The 3 remainder will go to the left of 5, so it will become 35. So 7 5s are 35. So here we can just do like this. You can use this 0 to here, then decimal will move one place to the right, because when we multiply decimal to zeros, the zeros push the decimal to the right. If you divide by 0, 10, 100, divide, decimal move left. But since we are multiplying here, decimal will move right one place because only 1 0. So it will become 7.5 when these two are multiplied. Multiplied it to 22 is our answer. 2 5s are 10. 2 7s are 14 plus 1, 15. Same number, so we can just write the same thing here. 0, 5 and 1. So we add them. We're going to get this. Now we have to determine the position of the decimal. So decimal means on the right of point, as I've been saying so frequently now. So only one place. So only one place. Start from the extreme right in the sum here. The sum that we got here, 1650, and move one, only one, so one place left. So 165. 165 centimeter square. This is the curved surface area value. Let's go to B2. I think we can do that also. So here, B2. Find the total surface area of cone if slant height is 21, diameter is 24. So let's draw the cone. So slant height is 21, so from here to here, 21 meter. Diameter is 24, from here to here now is 24 meter. We have to find the total surface area. So total surface area is here pi r into L plus r. So we need, what do we need? Pi we know, 22 by 7. R we need, L then we can find out. So R and L has to be there. So here, for the given cone, R radius 24, diameter divided by 2 meter. These 2 ones are 2, so 12 meter is the radius of the cone. Then L, the slant height, is 21 meter. It's slant height. So we need R and L only to find that. See, 22 by 7, R and L. Then we can find out total surface area. Therefore, the question is saying total surface area. So its total surface area will be pi r into L plus r. You can see here. So pi not given means 22 by 7 into r here 12, then L here 21 plus r again 12. Close the bracket. Then area means you can just put ones at the back. Always 2 dimensional, so meter square. So 22 by 7 into 12 into 20, 33, right, 33. So meter square. So we need to multiply this. So let us do this. 22 into 12. So 24, 462. When we multiply these two, then multiply to 33. That's our answer on the numerator. 3 4s are 12, 1 in hand. 6 are 18 plus 1, 19. 2s are 6 plus 1, 7. So same numbers here again, 3. So 2, 9, 7 we repeat. Then 2, 11, 17, 8, 7, 1, 2. So 8, 7, 1, 2 divided by 7 meter square. So we can divide that number. So if you divide 8, 7, 1, 2 divided by 7. Then we're going to get here 7 ones are 7, 1 in hand, bring down this 7, 7 twos are 14, 3 remainder, then bring down the 1, 4s are 28, 29, 30, 31, 3 remainder, so 3, then bring down the 2, and 7 4s are 28. Okay, so I think it's matching the book answer. So 28, 29, 30, 31, 32, 4 remainder this time. So no more digit means point, you can put 0 here. Go to third place. 7 5s are 35. Then 5 remainder, 0. 7s are 49. 1 remainder, right? Point means we can put 0, and then 7 1s are 7. So go up to third place and write that once. 1 2 4 4. 0.571 meter square, because the textbook is digging up the second place, so we need to go to third place of decimal first, second, third. After point is called decimal on the right side. 1 2 3 places. Then final answer should be second place, means we look at the third place of decimal. If it's 5 or more than greater than 5, the second place just in front of it will increase by 1, it will become 8, but here is less than 5, so nothing will change. 57 so meter square. That's our answer for total surface area. Okay, so B2 done. Can go to B3. So B3, yeah. Curved surface area of a cone is 308 centimeter square. Slant height is 14 centimeter. Find the radius of the base and also the total surface area of the cone. So let's draw the cone. Something like this the cone is. Okay, so slant height is given 14 centimeter. Find the radius. So radius is unknown. And the total surface area, so L also we need. So we write here for the given cone, R is unknown, its radius, we have to find that. Then L is given 14 centimeter. The slant height. So since the question is saying curved surface area is 308, so its curved surface area is 308 centimeter square. Look into your question, it's written like that, right? We can use this to find the R. Let's see. So next here, that implies curved surface area formula pi RL, as we can see it from here. Replace the curved surface by pi RL. This means you can put equal, and then 308 centimeter square. Then here 22 by 7 into R is unknown, we just read it. L is given here 14 centimeter equal to 308 centimeter square. 7 1s are 7, 7 2s are 14, we can cancel. So this R, keep it on the left side still, and then here 308 centimeter square, so we can just keep it. We shift this 22 on the numerator and go down to denominator. This 2 centimeter also will go down to the denominator. So this centimeter cancel to the power 1, and 2 minus 1 power, only 1 left centimeter. And 2 1s are 2, 2 1s are 2, 3 means 1 remainder, so that 1 will go to the left of 0 and make it 10, so 2 5s are 10. Then no remainder, 2 4s are 8. 11 2s are 22. 11 1s are 11. 12, 13, 14, 15. So 4 remainder. which will go to the left of this 4 and 44. So 11 4s are 44, 2 1s are 2, and 2 7s are 14. So we got the value of the radius 7 centimeter. So this is number 1. You can write your 1. Look at your question, radius of the cone. So this is your answer for radius. And number 2. Let's go to 2. Therefore, its total surface area is equal to, since you have written up to here, I'm going to wrap it out. Curved surface area is equal to a total surface area. Formula is pi r into L plus R. So we write that one. For pi we put 22 by 7. Then R, just now we got 7 into L is 14 plus R is 7 again, and here centimeter square, right? So this 7 and 7 can cancel off because there is multiplication sign here. And 22 into 14 plus 7 is 21. So that should be our answer. 21 multiplied to 22. 2 4, so 2 4. 462. So second answer is 462 centimeter square is the answer for total surface area. This is the rough things that you can write. Okay, one more question. That is B4, the last one. B4. A conical 10 is 10 meter high, radius is 24. A conical 10. Meter high means the vertical height. This one. If they say height, that means the height, vertical height. Unless they say slant height, height is always this one line joining a vertex to the center of the circle at the base, center of the circular base. Height is 10 and radius of the base is 24. So from here to here, radius is 24 meter. Find number 1, slant height of the 10. To cost of canvas required to make this tent at a cost of 1 meter square is rupees 70. So here, for the conical tent, R 24 meter is its radius. Okay, then H is a slant height here, 10 meter. Also height, not slant height. Height means the vertical height. Asking you to find L. Question mark. Let's do like this. Now, number 1. Since we know by formula, one formula, L is equal to root over H square plus R square. So put that. Because we know H and R, that's why we are taking advantage of that, H and R. So 10 square plus 24 square. Root over 10 square means 10 tens are 100. And 24 square means 24 multiplied 2 times, right? 4 4s are 16, 1 in hand. 4 2s are 8 plus 1, 9. 2 4s are 8, 2 2s are 4. So this is 6, 17, 1 in hand, so 5. 576. So this is root over 100 plus 576 is 676. Okay. So let's try this. I think 26 square may be this one. You can try it on your rough. 6 6 are 36, 3 in hand. 6 2s are 12 plus 3, 15. 2 6s are 12, 1 in hand. 2 2s are 4 plus 1, 5. So this is 6, 7, 6. So exactly 26 into 26 is 676, this one. So 26 double will come out as single out of the root. And 26 meter is the slant height value. First answer. Then go ahead and do the second answer. answer is number 2. We have to find the cost of canvas required. So if you're going to make this tent, you're going to cover it with a canvas cloth on the curved surface only, because that is to cover the tent. We will not put canvas on the floor, right? So only curved surface is the area of cloth required. So since, I can write here, since its curved surface area is to be only covered, only, not the base, so it's not total surface area, because the base is not going to be covered. We're going to put covering only on the curved surface. That's why the area of the canvas cloth should be the curved surface area. So therefore, area of canvas required, will be its curved surface area, which is pi RL. So 22 by 7 into R here we can see 24. L we just now got 26. Right, so R 24, L 26. And area means meter square, so we just put your meter square in the back. Then here, that will be equal to 22 by 7 into, okay, so you can just multiply it. It's 2, you can multiply 26